Hello everyone, our group researched the community of Volcania. Now we will talk about the site, culture, and history of this place. First is the site analysis. Volcania is a small town in the northwest of New South Wales. It's 948 kilometers away from Sydney, so it's a very remote town. The town depends on the Darling River for water. From the map, we can see that Volcania has a BSH climate. This means it's a mid-altitude steppe and desert climate area. The weather here has little rain, big temperature changes, strong sun, and fast water evaporation. This is the first graph. It shows the temperature in Volcania over the years. We can see that the temperature is rising, and most years after 2001 are very hot. The second graph shows the rainfall. We can see that the rainfall is not much, and after 2001, droughts happened more often, so we think that because it's hotter, water evaporation faster, and the town has less water. Because of its location, Volcania's water mostly comes from the Darling River, but due to climate change, overpumping, and blue-green algae, the river stopped flowing through the town in 2018. Now, water has to be transported from another town, 200 kilometers away. In 2024, the government started to fix this problem. The old weir, a kind of dam, was built in 1942. It's too old and cannot hold enough water. So, they are building a new weir 5 kilometers away. The new one can store 20% more water and help fish and the river, but it's not finished yet. There is also a backup plan, underground water. Because the water may be dry, Volcania has underground water brought to help in dry times. The government is also planning to study artificial underground water storage. Now about soil, plants, and animals. Volcania's soil is red and not good at keeping water, so only dry climate plants can grow. I found some plant pictures. Most have small leaves. This helps them keep water by doing less photosynthesis. For animals, there were new reports about many fish dying because there is not enough water. Fish, shrimp, and shellfish are gone. Birds and kangaroos are also affected. People lost many traditional food sources. From the map, we know that Volcania is very flat. Its average height is 79 meters, and the difference between high and low land is less than 30 meters. This flat land cannot keep water well, and it's hard to from lakes or ponds. Based on the climate, soil, and animals, I thought of 3 design ideas: roof water collection systems to catch rain, rain gardens with local plants to collect and soak rain, solar-powered water collection machines. Drought can also cause other dangers. I looked at this problem through 4 parts: ecosystem, public health, infrastructure, and culture and community.
Hi, my name is Yunxi Cai, and I will talk about the cultural analysis part. The first is cultural value. For the Volcanian people, the Barker is more than water, it's the embodiment of their ancestors. Barker flows always beneath our feet is the belief that connects land, water, and spirit. And also their cultural value lies in deep respect for country. But today, with the river dry, the voices of the ancestors fall silent. The next part is cultural expression. The first is artistic style. The Barkani express their culture through line-based art, symbolizing connections to land, water, and ancestors. These are more than aesthetic, they are cultural narratives. The second is traditional language. The Barkani language, once endangered, is now being revived through community-led schools. These efforts reconnect the younger generation with their identity. The third is cultural heritage. Barker Cultural Centers is constructed from local climate-suited materials like rammed earth. It absorbs the rain just like country, reflecting the community's connection to water and survival. Next part is multicultural influence. While Kenya is a culturally diverse town, where Aboriginal and non-Aboriginal residents make up roughly equal parts of the population, with Aboriginal people being the majority. This diversity requires a design that both respects Barkani culture and encourages cross-cultural understanding and cohesion. We implement 3 strategies to support cultural harmony. The first is preserve native vegetation. The design offers a shared environmental language that fosters collective belonging. The second is bilingual, which serves both cultural respect and practical communication. The last one is shared space like kitchens, gardens, and water points to encourage daily interaction and cultural exchange. Next part is political environment. In the past, the Barkani community called for fair water rights, a halt to industrial expansion, and excessive extraction. In times of drought, water represents not just survival but identity. After decades of political struggle, the Barkani were formally recognized in 2017 as traditional owners of the river, restoring their right to speak for the Barker. Today, the community can directly participate in managing the river, a vital step towards cultural justice. Next part is social support. While Kenya has a relatively high proportion of youth and elderly, and a prolonged drought has worsened health outcomes, especially chronic illness and mental health issues. To respond, our design introduced 3 key strategies to strengthen support in this drought-affected region. The first is accessible facilities for elders and people with mobility issues. The next is health service station. Mobile health units allow for regular checkups and chronic illness support. The last one is local health personnel training program to creating a self-sustainable care system within the community. Next one is risk management and resident safety. Prolonged drought has led to the disappearance of native plants like trees once used for cultural purposes. This is not only an ecological loss, but also a break in intergenerational knowledge. To address this, our design focuses on 2 key strategies. The first is rainwater harvesting system with sloped roofs and storage tanks. The next is community education to raise awareness about the connection between plants, water, and climate, promoting ecological restoration through local knowledge and participation. The last part is ongoing issues and future challenges. The most urgent issue today is drought. Prolonged dry periods have led to cracked land and dried riverbeds, threatening both cultural practice and daily life. Our response is to implement a rainwater harvesting system to improve water access. Looking ahead, the greater risk lies in health impacts caused by long-term drought, especially for elders and those with chronic illness. To address this, we propose a local health station model, blending mobile care units and local caregiver training to protect vulnerable groups in a culturally sensitive and sustainable way.
Now I will talk about the history part. First, I will talk about the background of drought in Wild Kenya. Wild Kenya is located in the far west region of New South Wales, a semi-arid climate zone that is characterized by high evaporation rates and low precipitation. But in the past,
Aboriginal people lived with the land well. They moved in different seasons and used special waterways, like soakage wells, to get water. The first reason for drought is colonial invasions and the destruction of traditional water management systems. In 1835, Major Thomas Marshall came to this land. Then colonists started to take the Barkangee people's land and water. Aboriginal mobile living systems were transformed into centralized settlements. From the 1930s, they lived in small camps and humpies. The second reason is the overexploitation of the Darling River system. Darling River is the main water of Wilcannia, but in the 1900s, heavy upstream pumping for large-scale agricultural irrigation. The unbundling of water licenses and water trading practices contributed to over-allocation and water speculation, further exacerbating the problem. So the river in Wilcannia has less water, bad quality, and has blue-green algae. The third reason is infrastructure deficiencies and delays. Wilcannia well was built in 1942, but now it doesn't work. In 2024, the government started a refill to replace the well, but the project is still not finished, so nothing has changed yet. Then I will talk about 3 examples for solving drought and water problems. The first example is from South Africa. In many places here, people walk long distances to get water. They carry heavy water in bad ways. But Q-drum is a plastic water container shaped like a donut. It can hold 50 liters. People can roll it on the ground. It is made of LLDPE. It's a strong plastic, so it doesn't break easily. Q-drum is highly resistant to compression and can be stacked up to 40 filled drums, exceeding international attacking requirements. This makes it easy to store and move. This product saves time and energy. In Wilcannia, some people need to go 200 kilometers or more to get water, so this idea fits well. The second example is from Waka village in Cameroon. Water security cannot be guaranteed here, and water sources are contaminated, affecting human health. Waka Tower can collect water from the air, like rain, fog, and dew. It uses natural and local materials. All parts are biodegradable or can be recycled. This is good for the environment. Wilcannia is very dry, but even in dry places, there is still water in the air, so this idea can also be useful. The third example is a dynamic landscape biological system. This is a design to fix algae problems in the rivers. The project corresponds to 6 different solutions for different types of algae, controlling algae pollution while using this common natural material as a medium to convert algae into electricity and fertilizer, contributing to the landscape and the environment. This is useful for Wilcannia because they also have problem with blue-green algae in the river. At the end, I want to talk about my design directions. There are 3 main ideas: architecture design, product design, and public place design. First idea is to collect rainwater from the roof and store it in tanks. Second is to use a water purifier and a water sensor card at home. Third is to build a central shade place with a fog water collection system. And then this is our frameworks and methods. And there are the references we used. Thank you.